What's up, everyone? I hope you are having a great day today. We are just going to get right to it and start with our wildlife wild fact. Red pandas are found in the Himalayas and in southwestern China. The name panda actually means bamboo eater, which is why they look nothing like their black and white cousins. Did you know that red pandas were actually named panda 50 years before their black and white cousins? I think that is pretty cool. I honestly can't think of any other jokes to make with this mug, so get used to it. To learn more about red pandas, check out the links in the description below. That's so good. Ladies and gentlemen, today we are doing LEETCODE problem number 45, Jump Game 2. This is a hard question and it's got 3,664 likes. I'd say people like this problem. The question says, given an array of non-negative integers, nums, you are initially positioned at the first index of the array. So that's the 0th index of the array. Each element in the array represents your maximum jump length at that position. So the number in each index represents the number of spaces we can move from that index. Your goal is to reach the last index in the minimum number of jumps. And you can assume that you can always reach the last index. So there will always be a solution for this problem. If we look at example 1, it shows us an array 2, 3, 1, 1, and 4. So the minimum number of jumps to reach the last index is 2. We can jump one step from index 0 to index 1 using this 2 right here. So from index 0 to index 1, and then because of the 3 at index 1, we can jump 1, 2, 3 spaces to get to the last index. Even though the next array is different, it's also an output of 2 for the exact same reason. We can move from index 0 to index 1. And then we can move 3 spaces from index 1 to index 4. 1, 2, 3 spaces. There you go. So if we start this problem, I'm going to start with an edge case. The most obvious edge case to me is if we have an array of length 1, well, obviously we don't need to go anywhere. So we'll just return 0. So if nums.length is equal to 1, let's return 0. No jumps are necessary, so we return 0. Now we don't need to have an edge case for if there are no numbers in the nums array because we were told that there will always be a solution for this problem. Moving forward, I'm going to start with 4 different variables, one called slow and another called fast. Those are going to be my 2 pointers for this solution. I'm going to store my current max number of jumps in a variable called next possible max, and then I'll store my overall number of jumps as well. To start this solution, we are going to use the fast pointer for our outer loop. So I'm going to say while fast is less than nums.length minus 1, because that second to last index is going to be the last index we ever need to calculate, since we're only trying to get to the last index, not out of the array entirely. The inner loop is going to go while our slow pointer is less than or equal to our fast pointer. Essentially, we are going to calculate all of the number of places we can jump from the beginning of the array every time up to where the fast pointer currently is. And in order to calculate that, we're going to say that our next possible max is going to be equal to a math.max between itself and the slow pointer value plus the slow pointer's value in the nums array. For instance, in this first example, at index 0, that would be 0 plus 2. So the answer would be 2. At index 1, it would be 1 plus 3, because from index 1, we can go 3 spaces to index 4, hint, hint. And every time we calculate that, we need to increment the slow pointer. Then simply we're going to move the fast pointer to wherever that next possible max is. So we say fast is equal to next possible max. Every time we go through that, we will have made 1 jump. So we add to our jumps variable. And finally, at the very end, we can return jumps. Run the code, get the right answer for that one test case, and submit the code and get the right answer for all the test cases. Ladies and gentlemen, that is Jump Game 2. Let's run through an example. So we'll take this first array as our example, put it in a comment, and start from the top. Slow is 0, fast is 0, next possible max is 0, and jumps is 0. The first thing we do is we say while slow is less than or equal to fast. So slow is at 0 and fast is 0, they're still equal. We go into this while loop. And next possible max is equal to a math.max between itself, which is 0, and slow, so 0 plus nums at slow, which is 2. Next possible max becomes 2. And what happens is we break out of this loop and fast goes to next possible max. So we move fast to index 2. Now, slow is less than fast. So we break into this loop and we say, what's larger? Next possible max, 2, or slow, which is 0 again, plus nums at slow, which is 2. Well, they're equal, so next possible max stays the same, and we increment slow to 1. Okay, what's bigger? 2 or 1 plus 3, which is 4? Well, 4 is bigger, so next possible max becomes 4. We increment slow to 2. 2 and 2 are equal, so we go one more time, and we say, what's bigger? 4 or 1 plus 2, which is 3. 4 is bigger. We increment slow one more time, and we end up breaking out of that loop. Now, fast becomes next possible max, which is 4. And we, by the way, should have incremented jump now twice. That is now our answer, and we go ahead and we return 2. So that, ladies and gentlemen, again, is our run-through of Jump Game number 2, LeetCode problem number 45. It is a hard question on LeetCode. If you like the wildlife wild fact, let me know in the comments below. If you like this problem or have any other problems that you would like me to solve, put those in the comments below, and I will see you in the next one.